Welcome to this video on the question, why does light bend when it enters a new medium? This is part one of the answer, and it's going to sidestep the question just a little bit, and in part two, we'll pull it all back together again. So in the previous few videos where we've been looking at different forms of refraction where light has hit a boundary between two substances, in this case we have substance 1 having a lower refractive index than substance 2, and what we saw happen in this case over here was that the light bent towards the normal. So the angle of incidence is greater than the angle of refraction. Now we know that the frequency of the light is not changing because we see the exact same color in this visible light example as it passes into the new medium, but we do know that the speed of the light drops, so it decreases as it goes into here, and we said that that was represented by the fact also that the wavelength drops. But why do all these things happen? That's really the question we're trying to answer. So we're going to jump back to the 1600s, and Francesco Grimaldi was a Jesuit priest who lived in the 1600s, and he was the first to coin the term diffraction. Now we've sidestepped this word refraction, which is a kind of more 50,000 foot view of what's actually happening, and we're zooming in on this term diffraction. Now in a basic sense, the word diffraction is the behavior of light as it encounters an obstacle or it encounters a small opening. So here's an example. This is a room we are seeing from above. So you imagine this room being completely dark and there's a white sheet pinned up on the back wall. Now I've just kind of made it stick out here so we can see where it is. There's a little opening on one side of the room. And what happens here is that light is shown at this little gap, but also at the entire wall. Now, the way that this light is represented here is a little bit confusing, so let me explain that to you really quickly. We're looking at a bunch of waves from above. So if you were thinking of it being representing a ray, you would think maybe the ray is a bunch of rays of light that kind of look like this. Okay, so there's a whole lot of light coming towards, and each of the green lines here is a crest of the wave, and each of the white spaces is a trough of the wave. So you're kind of looking at the wave from above, or a whole lot of waves lined up from above. Now the weird thing that happened, now I'm using green light, sorry, just to give you a heads up. I'm using this green color to represent, but it's really white light that was used in this experiment. But it's hard to see the white on this page if I use white highlighter. So I'm using the green here so you can see it. Now what happened was when the light hit this little opening, what we basically saw happen was that the light started to do this weird curving thing like this. And when it finally did hit the wall here, we had a wider gap. So I'm just drawing the edges of what the light looked like. The light hit the screen over here at a wider gap than the opening. And in addition to that, what we could say was that the rays, these black lines that represent the rays of light on top of these crest trough representations, that it actually did something that kind of looked like this. So if you were going to draw these rays coming through here, we see something that kind of looks like this. Okay, a very rough estimation. Now in addition to this really cool effect, what happened was that Francesco Grimaldi actually ended up putting a rod, a metal rod, and we're going to see it from above here, so it's just going to look like a little dot, a metal rod in the cone of the light. And on the shadow was a little bit wider than what would be expected from the exact object here, which makes sense if the cone of light's wider than the opening. But in addition to that, now this is the part where the fact that this is green light is a little bit silly, but basically what happened was he saw this rainbow effect. So he saw red light on the edges of the fringe of the shadow, and then obviously orange, yellow, green, and then blue and violet that was closest to the shadow, like this. So there was this rainbowing effect on the edges of the shadow that we had over here. So the basic thing to take away from this was that light that had these very organized crests and troughs, like waves that were coming in towards, or you could think of it as a ray coming in towards this opening. When it hit the opening, there was some redirection of the light, which didn't make sense because we were going into air and we were coming from air over here. So this whole thing wasn't the reason that it was bending. So what the heck was happening? Well, if we take a look at this image that I took from Wikipedia, and I have a link in the description below so you can check out the original source material. This is a picture from Wales in the United Kingdom. And you can see here that waves are coming in these big kind of lines where we have the crest of the wave and then the after trough of the wave and then another crest. And they're all hitting this rock face in basically straight lines. But when they hit the rock face and they hit this little opening here, we see this rounding effect of the wave. You can kind of trace those little crests and troughs of the wave. In addition, over here on this side, you see some weird cross-hatching that's starting to happen, and that's actually something else that we're going to take a look at in following videos. So the next step to understanding this was asking the question, why is the wave starting to round out like this? We're going to take a look at that in this next part, where we look at Christian Huygens and the Huygens Principle, or the Huygens Principle. So Christian Huygens proposed this idea that a wave front, which is what we're going to call this part of the wave. So we're going to think of the wave now moving in this direction. So if we made up a whole lot of rays along this set of lines here, remembering that we're looking from above, and each of these is a crest, and each of the gaps in between is a trough. And so what we're going to do here is call this the wave front. So that's just the propagation front of the wave. Now what Huygens proposed was that when you hit an opening, because each of these wave fronts that is propagating forward, he says are made up of individual wavelets. Now a wavelet is a point source, similar to how we talked about a charge being a point source of a wave. So what he says is that each little point along this wave is the source of the next wave. And so the way that he describes this is in the following terms. So he talks about the idea that if you have a light source, around that light source you have these waves forming that are spherical. And if you think about that, if you have a candle or your phone flashlight on in a dark room, you can see the light in all directions. This, of course, is a two-dimensional representation. It could be three-dimensional as well. You see it in all directions. And what you notice is that not only does the light intensity decrease as you consider it from a point further away from the source, but these are spherical patterns, right? So each of these lines, similar to these green lines, is a crest, and each of the spaces in between are troughs. And so what he says is that when many of these point sources, so we'll draw a second one here in a different color. Sorry, mine aren't very pretty, but it will get the point across. The second point source on the line, let's get that one a little bit more round. He says that when you have a whole lot of these point sources all along, all of the corresponding points to this would form a net wave front. So if there were a lot of point sources all the way next to each other, you can think about each of those concentric circles as having a tangent point or front to it, and they'd all add up and make the front of the wave, depending on which direction you were looking at. So when you reach an opening such as this, you're really isolating one of the tiny little point sources on the wave. And so when it hits this point over here, what it will start to do is curve outwards because you've isolated it from the rest. So really, you're pulling just one of these sources, or maybe a few different sources depending on the gap size in the wall. And that is in fact what we have been able to support with even quantum physics ideas, which were discovered hundreds of years after Christian Huygens and the Huygens Principle was proposed. In part 2 of this video, we're going to take a look at how we will tie it back to this idea of the refraction of light that is occurring, and we're going to tie diffraction and refraction together.